One flick throws sparks hotter than 3,000 degrees Celsius, and they aren't burning gas, they're burning metal. Every disposable lighter is doing something closer to a tiny meteor shower than a candle. Roll the wheel, and in a fraction of a second you get light, heat, and flame, all from one thumb motion. So what is actually on fire in that first instant, before the flame even shows up? Pop one open, and there are really just three players. A ridged steel wheel under your thumb, a soft gray rod pressed up against it by a tiny spring, and a reservoir of liquid butane, waiting behind a valve, kept liquid by its own pressure until it hits open air and flashes into vapor. None of those three things, on their own, looks like it should make fire. The wheel is just machine metal. The rod is soft enough to scratch with a fingernail. The butane is just gas under pressure, the same stuff in a camping stove. The spark comes from getting two of them to fight. Here's the part almost everyone gets wrong. That gray rod gets called flint, so people assume it's a chip of actual flint rock, the same stuff that sparked old muskets by striking steel. It isn't. Real flint sparks by knocking hot iron shavings off a steel striker. A modern lighter rod contains no flint at all. It's a man-made alloy, and the spark comes from the rod itself, not from any rock. The rod is called ferrocerium, a manufactured blend of iron and rare earth metals like cerium, cast to be soft and brittle on purpose. That softness is the whole design. When the ridged wheel rakes across it, it doesn't just scratch the surface. It shears off tiny flakes, some no bigger than a speck of dust. Those flakes are the fuel for the spark, and shaving them loose is the wheel's entire job. Here's the payoff. Those flakes ignite themselves instantly just from being torn off. Ferrocerium is what's called pyrophoric. Tear a piece loose, and the fresh, jagged surface reacts with oxygen in the air, so fast it ignites on contact. No flame required. The friction of the wheel barely matters for heat. It's there to physically rip the flakes free. Each one flares past 3,000 degrees Celsius for a fraction of a second, a shower of white-hot metal dust, gone before it even lands. None of that burning metal would matter without perfect timing. Press the lever, and a valve opens a hair before the wheel spins, letting a thin cloud of butane vapor drift up around the burner tube. Flick the wheel a half-second later, and that shower of pyrophoric sparks lands right inside the waiting gas cloud. One of those white-hot flecks is more than enough to set the vapor alight, and the flame you see is actually the butane catching, not the spark itself. Get the order wrong, spark before gas, or gas without a spark, and nothing happens at all. The whole mechanism only works because both events are chained to the same single motion of your thumb. A single lighter rod holds enough ferrocerium for thousands of these tiny explosions, one per flick for the life of the lighter. Each strike shaves off only a few milligrams, invisible to the eye, which is why the rod slowly shortens over months of use instead of disappearing after one light. That's also why a lighter fails a different way than you'd expect. It rarely runs out of sparks first. Usually the butane empties out while there's still plenty of ferrocerium left, so you keep hearing that dry, sparking click with no flame to show for it. It's a controlled, repeatable chemical reaction, engineered to survive your pocket, your car, and a decade in a kitchen drawer. So the fire in your hand didn't start as fire at all. It started as a spray of self-igniting metal shavings meeting a puff of gas at exactly the right instant. Not a rock, not magic, just ferrocerium doing chemistry on purpose. If you'll never flick a lighter the same way again, that's the whole point of this channel. Subscribe at Cutaway 360. We keep cutting things open.